Hi friends, in this particular video, I'm giving you brief idea about various memories. Okay, so in the previous videos, I explained the minimum mode, maximum mode operation of 8086 and their timing diagrams. Whereas here, let us see what are the different types of memories. Okay, and what are the corresponding ICs and what are the various bits present in the memories. We'll see in detail here. Okay. See here, so memory interfacing. See here, memory interfacing. So in that, let us see in detail. So we have four common types of memories. If you take any memory into account, there are four main types. One is call it as a read-only memory, call it as ROM memory. It's a read-only memory. Okay, then other is flash memory, also call it as a EEPROM, nothing but electrically erasable, programmable, read-only memory. It's a EEPROM. Then other is two RAMs are there. One is called it as a static RAM, static random access memory. Short name is SRAM. Then other is dynamic random access memory. Short name is DRAM. Like that, we have four different types of memories. So depending on the function, it is changing from one memory to other memory. Let us see if you take in general, if you take any memory, what are the various pins present? Okay, generally if you take a first for any memory considered into account, so there should be three different devices. One is called it as a address inputs. So there are some set of address pins are there. So depending on the size of the memory, address pins are changing. For example, if memory is 1 megabyte, having some set of address lines, 1 kilobyte, other set of address lines, 1 terabyte, other set of address lines, like that. Address inputs are changing from one memory to other memory. So one important one is address inputs, nothing but address lines present in the memory. Then other is data inputs and output. Generally data lines are bidirectional. So your memory is receiving data or sending data depending on the type. If it is ROM, only read-only memory means we can read data from the ROM memory. It's not possible to write data. Whereas RAM, both read and write are possible. So like that, two sets of pins. One is address lines, other is data lines. Then other third important one is the selection pins. So in order to select that particular memory, we should enable some control pins. Then only that particular memory is performing either read or write. So selection pins are also important. So in generally, if you take any pin diagram of memory, we have three different set of pins. One is address pins. Okay, then data pins. Address pins are unidirectional, whereas data pins are bidirectional, and selection pins are there. Okay, let us see detailedly. So coming to address connections. Generally, all memory devices have address inputs that select a memory location within the memory device. Generally, the address inputs are labeled from A0 to AN. For example, I need to select a memory of 1 megabyte. Then it is 2 power 20 is 1 megabyte. So how many address lines are required? 20 address lines. In that case, A0 to A19. For example, my memory is 1 kilobyte. So in that case, I need to select 10 address lines. 2 power 10 is 1 kilobyte. So I need 10 address lines. In that case, it should be A0 to A9. Like that, depending on the size of the memory, the number of address lines are changing. That's why he mentioned A0 to AN is the range. So coming to other one is data connections. See, generally all memory devices are capable of holding 8-bit data only. Only address lines are changing, but the data line should be 8 only. And remember one more point is total memory is divided in the form of two banks, even bank and odd bank. For example, if you take ROM, even ROM, odd ROM. So even ROM contains all even addresses, whereas odd ROM contains all odd addresses. Okay, now I will go in detail later on. All memory devices have a set of data inputs lines. So data lines are also required. Generally 8 data lines are present preferably, but only thing is address lines are changing from memory to one memory to other memory, right? Then other is a selection connections. So in order to select that particular memory, there are some selection pins are there. Let us say each memory device has input that selects or enables the memory device. So memory is a one chip. In order to select that particular memory, we should enable some selecting pins. The various selecting pins are from memory to memory, it will change. So one is called it as chip select, or short name CS. This should be enabled. Then only we can select address lines and data lines, and accordingly we can perform either read or write operation with the help of memory. So in that case, this pin is essential. Chip selecting pin, Some memories may have chip enable related pin, that is called it as CE. Some may be have only select pin, yes pin. Some may be having output enable, like that. One IC to other IC, these pins are changing, but one must be present. Minimum one must be present for any memory selection. Maybe chip selecting signal CS, or maybe chip enabling, or simply chip selecting only, or output enable, like that. One must be present. So these three are very, very essential. So what are those? Address connections, data connections, and selection connections are essential for selecting any memory. Okay, so address connections are vary from memory to memory, whereas data connections are only 8 data lines. Okay, for example, if processor is 16-bit, then lower 8 data lines are available, higher 8 data lines are available. Accordingly, we are selecting. Selection pins are also required. Among these, any one should be required. Then coming to other one. This is also important. This is the simple overview of any memory device. Here we have address lines, set of address lines, call it as address connection. Here A0 to AN indicates address lines, and similarly data lines are there. Okay, in that I mentioned O0 to ON. Generally we can call it as D0 to DN here for better representation. So data lines are bidirectional, input or output, whereas address lines are unidirectional. So depending on the memory, we have read bar signals, write bar signals, and select signal. If it is ROM memory, only read bar is available. If it is RAM memory, both read and write are possible. Means RAM performs read operation as well as write operation. In that case, read, write are essential. So in addition to that, we have some chip selecting signal, CS, chip selecting bar. Okay, something like OE bar. Okay, all are appeared for any memory. Okay, like that, we have three set of signals. Input selecting signals, address selection signals, and chip selecting signals. These signals are connected to read bar or write bar from the external processor. For example, read bar and write bar are coming from the processor. For example, processor activating write bar, then what happens? Processor sending its data to memory. For example, processor wants to perform read operation, then we will take data from memory. Okay, externally we have processor here. Then let us see in this particular example, for example, if 11 address lines are present, here A0 to A10, total 11 address lines are present. Then what is the memory capacity? How we can calculate? See here, 11 address lines are present. So it is 2 power 1 into 2 power 10. So 2 power 11 now. So 2 power 10 is called it as 1 kilobyte. 2 power 1 is 2. So 2 into 1 kilobyte is 2 kilobytes. So your memory is now ready to hold 2 kilobytes of information. So 2 kilobytes. 2 kilobytes nothing but 2024 bytes. Like that, we can identify memory accordingly. We can identify how many address lines are present. For example, if it is a 1 megabyte memory, then 2 power 20, nothing but 20 address lines are present. Okay, then that should be 1 megabyte. Okay, that is 2 power 20. Like that, we can identify easily. So coming to other important point is, let's see other point. See, I already mentioned for every memory we have some selecting pins like chip enable, chip selecting, select pin. Okay, all are essential for performing read or write operation. Similarly, let us say other point. If it is inactive, for example, all these chip selecting signals are inactive, then what happens? So processor won't perform any operation. Okay, processor won't perform any operation. So your memory may not read or write. So if any chip selecting signal is inactive, so even processor is active, processor is sending request signal also. So the data transmission is not possible. So the chip selecting signals must be enabled. So selection pins must be enabled. Then only memory device is ready to read or write. Okay, data. So coming to control connection. So let us see detailedly. So already we know ROM usually has only one control input. If it is ROM, what happens? The ROM functioning is only read-only memory. So it will read data. That's why we don't have any multiple control inputs. Only one control input is present. Only one control input for ROM. If it is RAM, we have multiple. See here, if it is RAM memory, what happens? See here, often has a 1 or 2 control inputs for RAM, especially for RAM. So instead of one control input, we have many, at least one or more control pins are present. Because RAM, it performs read operation as well as write operation. So at least 2 control pins are present for RAM. For ROM, only one control pins because of read operation only it will perform. Okay, so various control pins for ROM also, maybe OE bar, sometimes gate signal. Okay, so finally, if you take any memory, preferably we have 3 different things. One is address selection pins, data selection pins, and control pins, nothing but activating pins. So whenever those activating pins are active, then only your memory perform read or write operation. So the other important point is see here RAM especially. RAM performs both read operation as well as write operation. RAM performs both read and write, and it contains one or two control pins. Okay, and performs both read and write operation, right? Okay, like that we can analyze read and write. Similarly, RAM and ROM. Now let us see what is ROM. Till now we just I mentioned it is read only, whereas RAM is performing read and write. Let us see detailedly. So here the ROM read only memory permanently stores programs and data was always present. See here, data was always present even when power is disconnected. So what is the meaning? So ROM memory, okay, stores data permanently. Even if power failed, then what happens? We are not losing data. It is stored permanently. Coming to, that's why it is called it as a non-volatile memory. So it is a non-volatile memory. What is the other one? EPROM. EPROM is a erasable programmable read-only memory. It's erasable programmable read-only memory. So now name itself, see here, it's another type of memory is EPROM, erasable programmable read-only. This memory is erasable. In which way we are erasable? So this here, if we expose a high intensity ultraviolet light for at least 20 minutes or less, depending on the type of EPROM, your data is erasable. So in order to erase the data in EPROM, what happens? We should focus ultra light at least for 20 minutes. Then only the data, whatever it may be the data present in EPROM, that is erasable. Okay, that is a EPROM. It's one type of ROM only. Okay, read-only memory only. Another type is PROM. PROM is a programmable read-only memory. Okay, this is also one more family of ROM. Then see here, there is a flash memory, also called it as a EEPROM. Okay, EEPROM is electrically erasable programmable read-only memory. Okay, so now this particular memory is erasable electrically. That's why it is called electrical erasable programmable ROM. Okay, EEPROM, also call it as a flash memory. Then other is EAROM, electrically alterable ROM, or also call it as a non-volatile ROM. Okay, like that we have many names are there. So ROM, in that many families are there. One is EPROM. Okay, then other is PROM, then other is EEPROM. Three comes under ROM family. Okay, so now all these are permanently stores data. Okay, even power failed also permanently stores data. That's why it is called as a non-volatile memory. Okay, now next point is if it is EPROM, there is a chance of erasable data only with some alternative arrangement like high intensity light is focused into it, then only erasable. So coming to other type is RAM memory. RAM is also called it as a random access memory. Okay, see here these memory devices are electrically erasable in the system but require more than RAM. So compared to RAM, okay, in ROM memories we can erasable data, but it is somewhat difficult. Now coming to RAM memory. The RAM random access memory is a read or write memory. Data lose when power is disconnected. So unfortunately when power failed, so whatever it may be the data present, we lose entire data. But it performs both read and write operation. It is also called it as a volatile memory. So volatile means we lose power, we lose data when power failed. Okay, that condition is called it as a volatile memory. So now there are some EPROM combinations are there. EPROM may have different IC numbers. Let us see here. So all EPROM starts from EPROM, erasable programmable read-only memory. So all starts from series 27666 series. Okay, let us see a few. 2704 is a one EPROM memory. In that it is data lines are 8. This first one is indicate data lines. Other indicates the capacity of memory. Here what is the capacity of memory? 512 bytes. Nothing but 2 power 9. Nothing but how many address lines are present here? Only 9 address lines are present. Coming to other IC 2708 IC. Here also data lines are 8, but here memory capacity is 1 kilobyte. Nothing but 2 power 10. Nothing but how many address lines are present? 10 address lines are present here. Then other EPROM IC is 2716. Here data lines are same, but address lines are now 2 power 11. Nothing but 11 address lines are present. Here 12 address lines are present. That's why 4 kilobyte. Here 13 address lines are present. Here 14 address lines are present. Like that. So all EPROMs vary address lines, but data lines are same. So what are the various sequence? 2704 is one combination. 2708, 2716, 2732. Okay. See. So based on this, we can understand 2764, okay, 27128. Like that, we have different EPROM families. Okay, so this is about the just overview of 8086, especially the memory related information. So till now, what is your observation? We have mainly two memories, ROM memory and RAM memory. ROM memory is a non-volatile memory, whereas RAM is a volatile memory. Okay, and RAM performs read and write operation. Okay, whenever power failed, what happens? The data we lose in RAM, whereas the data is permanently stored in ROM. And we have different families of ROM like EPROM, EEPROM, okay, and PROM. Three are there, right? So in all those ROM memories, we can erase data, but it is somewhat typical compared to RAM memory. That's one important point. And for every memory, we have three different connections: address connection, data connections, and selecting connections. So in order to select that particular memory, we should activate the selecting pins. So, and for ROM memory, at least one pin must be the selecting pin. For RAM memory, one or two selecting pins are present. That is the overview of all memories. And for EPROM, there are some IC numbers. From one IC to other IC, address lines are changing. Okay. Now, like that, we can analyze memory organization. Okay, and various memories present in the system. Okay. Now, thank you for watching this particular video. Okay, I hope you understand the introduction of memory. Okay, so in the coming video, I will explain how all these memories are interfacing to 8086. Okay, so please kindly share my video to your friends and subscribe.